This lesson is on mapping images. In our directions it says to explain how to map the pre-image onto the image. In number 1, we've been given a pre-image here, and then we're told what the image coordinates are, and since there are 2 primes, it means that there have been 2 transformations. Let's go ahead and plot this and see where our figure is at with these points. So we have 0, 1, -1, we've got 4, -2, and then we're going to have 5, 3. And right here, this shape right here, there we go. Okay, let's label our points. The A prime here, this one was B prime prime, and this one is C prime prime. Okay, if you look at the orientation of this, we know right off the bat it's not a dilation. It didn't change size. So then we want to check for reflection and rotation. When we look at reflection and rotation, we want to say, did the object actually turn? A rotation is possible because it could potentially turn around a fixed point here. But it also looks like a reflection is possible as well, because if you'll notice, like C was on the bottom before of the triangle and now it's on the top of the triangle. B was on the top and now it's on the bottom. So either one of those looks like they're a good route to pursue. I'm going to go ahead and pursue the reflection. When it looks like C and C prime switch places, it looks like they're flipping over this x-axis right here. So let's start with that and see if there is a reflection over the x-axis. And to do that, we're going to plot our reflection. So I'm going to grab a different color ink here. Here we've got A would then flip over, and this right here is where my A prime would be. B is 2 units away from this line of reflection, so here's 2 units right this way. And then C, which is here, is 3 units, would be 3 units this way. So this is right where my C prime is, this was my B prime, and this was my A prime. Now, again, if you look at this, I see the triangle there, and so the question is, how do I get this point here, and this point here? You'll notice that all of these points are a distance away from their prime. How much? 1, 2. This B is 1, 2. C is 1, 2. And so now I can say, well, I see that the next transformation is going to be a translation of 2 units right. And that would create a sequence of transformations in which we can get from this pre-image to this image. It doesn't mean it's the only way. There are other ways that this can work. However, it's just one path to getting there. All right, let's look at number 2. On number 2, we are now going to try to map the image onto itself, but we're only allowed to use one transformation. You actually have multiple options here. So we wouldn't want to do a reflection, because when you do a reflection, it flips it over an axis and you can't put it back. You could do a dilation. When you do a dilation, it means that you're going to multiply every single x and y by the same factor. Well, what could I multiply x and y here by that would give me the same factor, the same information? And that would be a dilation by a scale factor of 1. Anytime you multiply 1 by something, it's that thing. So when we do 1 times x and 1 times y, it's still x and y. Another way, another option that you could do this is a rotation. How much can you rotate this entire object so it maps onto itself? Well, that would be a rotation of 360 degrees. So 360 degrees. Some would argue that you could do a translation of 0 units up or 0 units right. That one's a stretch, but it's still technically a transformation. So now let's look at number 3. Number 3 says we want to map it onto itself, but this time we want to use 2 transformations. So if we're going to use 2 transformations, you either want them to counteract each other to be inverse operations, or you want them to essentially create a dilation by 1 or a rotation of 360. So let's look for example. We could say we want to reflect over the y-axis and then reflect over the y-axis. So that's kind of like doing it once and then you're flipping it back over. Or you could do something where you dilate by 3, then dilate by 1/3, because if you do 3 times x and y and then you divide x and y by 3, it'll get you the same amount. You could even do a rotation. You could rotate by, let's say, 90 degrees clockwise, and then you could rotate by the remainder of it that would make 360. So you could rotate it by 270 degrees clockwise, because if we added the total rotation here, it's 360 degrees and it would land back on itself. You have a lot more options there, but those are just a few.